In this video, we're going to focus on breaking down route redistribution. Now, like I've mentioned before, what we're going to be doing is actually taking the routing adjacencies and the routing domains outside of these squares, and the square and rectangle for OSPF and for eigrp, and we're going to be bringing them and we're going to be joining them on R6 and 13. So R6 and 13 are going to both be running OSPF and eigrp at the same time. And we're going to see how route redistribution would come into play with how that would work, and go from there. So I'm going to just expand the routing domains out onto 6 and to 13 from OSPF and from eigrp, just to get it up and running. And from there, then I will fall back to the slides that we have, so we can break down exactly how the technology works, what redistribution is, why it's important, issues you can run into it with redistribution, and go from there. Now, there's a question posted already, which I'm actually surprised there's a question already. But the question is, if you're doing route redistribution and you have to go from OSPF to eigrp, what is the actual intended purpose for redistribution? Well, from a high-level overview, it simply is bringing routes external to your routing domain into your routing domain, which could be simply a default route. You could be advertising a default route in from BGP, if you will. So there's different ways of doing that. So what I'm going to do out of the gate is I'm going to bring this guy up, and I'm going to go on router 3, and I'm going to go on router 3. I'm going to click on router 3. I'm going to go to global config. I'm going to type in router OSPF 3 and type in network of 36.0.0.0, and I'm going to type in 0.0.0.255 area 0. I'm putting this in area 0 because the fact that R3 is an ABR, and I don't want to be adding another area because, well, for one, I don't want to configure a virtual link to bridge area 0 over, so it's just easier to run it over that. And then on router 5, do something very similar. Come up here and go router OSPF 5, type in network of 56.0.0.0, and type a wildcard mask of 0.0.0.3 area 0. Because of 3, there's only 0, 1, 2, 3 of the addresses, and it goes into 4. 4 is going to be the base subnet, 5 and 6 are going to be usable, and 7 is going to be the broadcast. So I'm going to go down and hit the up arrow and go down and type this, do the same thing for 135. So 135 and hit enter, and that takes care of that problem. I go over to 6 now, go to global config, type in router OSPF 6, type in network of 36.0.0.0, 0.0.0.255 area 0, and I'll type in 56, and then I'm going to come over here, but this is going to be a .3. Then I'm going to go, and there's our adjacency loading over to 5, and 3 should be learning momentarily here. Do show IP interface brief. Do show run interface serial 2/0 PPP. Just make sure that 6 is running do show run interface serial 2/0 capsulation PPP. Oh, I see why. The subnet masks are different. So we look on 3, 255.0, and then 6 here. So we'll type in interface serial 2/0 and type in IP address, and that's a key thing here. If you run into a problem with that, if you run into issues where you can't get an adjacency to form, make sure the subnet masks match. And I simply just did that by accident. I had no intention of actually having an issue that pop up, but the subnet masks are different. So in 6 has got a 252, so a /30, and router 3 has a /24. So we're going to have to make them match. Now, depending on any issues you might come into, I always try to go based off of what the diagrams dictate. So if the diagram dictates a /24, that's what I need to give it. So I'm going to just type in 36001 and go to here, but I'm going to pull this guy out and hit enter, and that should bring up our adjacency. And then I'm going to type in router OSPF 6 and type in network of 60, or sorry, that's it for that one. And I'm going to type in router eigrp CCNP address family IPv4 autonomous system 789. Now there's another question out of the gate. Actually, I like this guy. That's why I take the questions as soon as I do. Why do you need to run 789 on 6? He's not inside the same domain. Well, if you don't run the same domain between the two, if you run, say, eigrp6 and eigrp789, they're not going to be able to communicate. Two different autonomous system numbers. If I wanted to go 6, I'd have to go 6 for just this link on 7 right here, and then 789, then redistribute the routes in between the autonomous systems. That's why we do it that way. So I'm going to type in network of 67.0.0.0, 0.0.0.255, and hit enter. Now I'm going to go down to router 13, go to global config, and type in router OSPF 13. And the reason why I'm using the router number as my process ID is to show you guys that it's locally significant. So I don't ever modify that. Normally it's router OSPF 1 and I'm done, and I don't really ever care. In this case, I want to make sure that I keep it consistent. Consistent in regards to using the process ID or the router number as the process ID. So 135.0.0.0, 0.0.0.3, area 0, and then we're going to type in, there goes the adjacency, we're going to type in do show IP interface brief. We do have a loopback in there, so the loopback should have shown up. We're going to type in, and we're going to type in router eigrp CCNP, address family IPv4, autonomous system 789, network of 137.0.0.0, 0.0.0.3, and hit enter. Now we're going to go to router 7. I'm going to type in global config, router eigrp 789, type in network of 67.0.0.0, and as well as 135, and then .3. So that should form momentarily. Do show run interface serial 2/2. Okay, that's correct. Just make sure 13 is correct as well. And do show run interface serial 2/1. Okay, so PPP. Let's make sure that 7 is set up for PPP. So, and it is. Okay, so .2 .1 do ping 137.0.0.2. Okay, I can ping it. Let's go to 7 and type in do show run pipe section eigrp. Let's just make sure I haven't done anything in here that I don't remember doing. Interesting. Okay. Well, 6 formed right away. .13. Do show IP interface brief. Make sure the ports are not shut down, and they're not. We know it's not a layer 2 problem, right? Do show IP interface brief because the pings worked. Do show IP eigrp interfaces. Serial 2/0. And let's type in neighbors. Okay, so I obviously have a problem here. Let's see here. Let's see. Do show IP interface brief. Do ping 192.168.79.9. Okay, so let's go to 9 real quick and show IP interface brief. Okay, that's up. Show run pipe section eigrp. Because eventually this will, when we start getting into the more of the details, let's see here, 79 and 89. Okay, they're in here. Okay, that all makes sense. Let me go back to 13 real quick and type in network of 137.0.0.0.1 and go to 7, do the same thing. So network of 137.0.0.2. I'm going to go, okay, there, that forms that one. So I don't know why it didn't form up to .3. And then on, type in network of 192.168.79.7 just to get it operational. And there it goes there. I saw it pop up. So it might not have been specific enough. So we're good to go. So now we have adjacency everywhere, right? If we go to 7 and do a show IP, 13. If we go to 13 and drop out here, we do a show IP route. We should have a bunch of eigrp and OSPF routes. So this is going to be our routing table. Alright, that's our routing table as it sits right now. You have the OSPF domain and the eigrp domain bridging together, right? So that's our routing table. Nothing too extreme, but if you notice, there's a lot of stuff in here that there's overlap, and there's a mix of OSPF with the eigrp, and I did that on purpose so that I would make sure that everything was coming across the way we needed to. So we'd have a little bit of overlap in our network and stuff like that. So that's where we're at with that one. Now what we're going to do is we're going to take a look at going in and taking a look at what redistribution is and the different ways you can work with it. So what the heck is route redistribution? Why would you need it? Well, the main reason why you would need redistribution is to get routes from external to your routing domain into your routing domain, whether that's just a default route or some other capability that you need to get into your network. Irregardless of the situation, you need to be cognizant that the capability is there and the different ways that you can manipulate that. Now, I've seen people break their routing domain by redistributing the wrong routes in or causing routing loops and stuff like that. And quite frankly, it can be just kind of a cluster if you don't know what you're doing. So I'm hopefully going to take the next little while and take a look at how that would work. Now, I'm not going to go super deep in redistribution. I don't think it warrants it, to be honest with you. As long as you understand the idea of what routes are redistributed, what routes aren't redistributed, then it pretty much kind of falls into play. So the idea behind it is you're going to be looking at two different ways of getting routes redistributed into your network. So you're going to have implicitly occurs for connected links running the redistributed protocol. So what this means is if you have additional connected links can explicitly be included or excluded. So as it redistribute connected, metric, route map, what have you, and overrides the implicit redistribution, which means that if you have an interface that matches the network statement and you redistribute that route in, that's going to get pulled in. Now, even if there's a connected interface and you're not specifically doing that, if you redistribute OSPF or you redistribute connected, depending on how you're actually redistributing. If you redistribute connected OSPF, and you're pulling more routes in, that can pull more routes in than you want. So there is a specific way to do that. So for instance, I usually do redistribute OSPF 1 and then whatever my details are that I need to do. And then I give it a metric for if it's going to be going from OSPF into eigrp. You have to be able to give the incoming protocol a metric that the receiving protocol can understand. Same thing with OSPF or eigrp to OSPF. If you're going to be bringing eigrp into OSPF, you need to give, you need to let OSPF know that you're going to it's going to automatically apply a cost to it, and then whether it's going to be E1 or E2, if it's going to add the cost throughout the network, or if it's going to just redistribute it with a value of 20 and then kick it out. All that type of stuff is determined at the point of redistribution. So that's the idea of what goes on. So how iOS chooses routes to use is routing database chooses one or more candidate paths. So basically what you do is if it's not in the routing database, it is not candidate for redistribution. That is the one thing in there. So any routes that are in there via connected are going to get pulled in as well, as long as they match a redistribution statement, for instance like redistribute OSPF, and as long as the interface is operational with OSPF, it'll get pulled in. So that means the routing process has to be up and operational on that particular subnet. Because remember, the network command in OSPF and eigrp doesn't actually advertise the route. It simply turns on the process on the interface. If another interface on the same connected link on the other end, if another router is doing the exact same thing and you guys form an adjacency over that connection, then that link will get advertised into whatever protocol. So that's the general idea of how it doesn't really make much of a difference. But if the routes are not in the routing table, they are not candidate for redistribution. So that's the main kicker that most people have a hard time grasping, is routing table good, out of routing table bad. So that's the general idea how it goes through. So because of the fact that redistribution, RIP and eigrp are distance vector routing protocols, they install routes through redistribution based on routes in the routing table. BGP redistributes routes that are the ones that win the best path selection process, and OSPF does pretty much the same thing, but by default will only redistribute internal OSPF. Why is that? Well, it's simple. Because of the fact that when you're dealing with the redistribution, if you have redistribution set up, you're bringing redistribution from OSPF into another protocol. Well, that's bringing OSPF routes that are internal to OSPF into another protocol. If you redistribute external routes too, they're already external to OSPF. So therefore, you would potentially you'd be able to learn them another way. Maybe you can't, and being able to redistribute them through OSPF is the only way to do that. We'll take a look at that as we go along. So the thing with RIP distribution is going to be it doesn't differentiate between internal and external routes. So it's an administrative distance of 120 for all routes. There's no seed metric by default, so you have to specify the metric and hop counts, because that's all RIP bases it off of. Now you can do the transparent capability, and the transparent capability says whatever the route was originated with, whatever I saw it come in as on my redistribution statement, that's what I'm going to carry it over as. So if the local router, you're going to be redistributing the route in, and the route is in the routing table, and it's got a hop count of 6, then you're going to be redistributing with a hop count of 6. Or you can say 3. The other thing too that's nice about RIP is when you're setting this stuff up, you can actually, if you're redistributing into RIP, you can set the seed metric to act as a limiter as to how deep inside the RIP domain that redistribution will come in. Okay, so let's say for instance you redistribute with a hop count of 13. That means 2 more additional hops into the RIP domain, and that bad boy has reached its 15 hop count limit, and it is no longer able to be propagated through the RIP domain. So it's one way for you to limit the scope of how far you're going to learn that route. Now with eigrp, we have an AD of 170 for external routes, and helps to automatically prevent route feedback. So prevents route redistribution problems. So route feedback means you advertise a route out you redistribute it on one router, and then another router learns it back in and potentially could reroute it out somewhere else. But I'll show you how to fix that problem. Uses router ID for loop prevention. If you are using older code, so for instance, if you're running 12.4 in older code, by default, only the internal routes will be redistributed. If you have a matching router ID on 2 different routers and you redistribute eigrp, what's going to end up happening is the external routes will not be propagated. So the general idea for that is to prevent looping in the network. So you can change that by removing the duplicate router ID on the router that doesn't belong with it, And because there's no default seed metric with eigrp, you have to assume that you have to apply a metric to it. And the metric can be applied 3 different ways. During redistribution, you type in redistribute and then the metric of bandwidth, delay, load reliability, and MTU. You could do default metric at the routing process level and state that any redistributed route is going to automatically get these values. And that's going to happen for any redistribution. Or you can set in a route map. In the route map, you can go in there and type in, you're going to be setting it up, and you'll set the metric and then whatever the values are. And so when you redistribute eigrp or redistribute OSPF 1, and you hit enter, and you're calling route map, say OSPF routes, what's going to end up happening at that point is the routes will be redistributed, and whatever you set the metric values to be in the route map will be applied to the redistributed routes that you're bringing in. With OSPF redistribution, it's a little more. It can be a bit more complicated. 80 for 110 for all routes, but uses router ID for flooding loop prevention. Again, if you receive your own route or your own router ID back in, you're going to drop the route. A default seed metric of 20 for all routes that are E2 or N2, which is a default, which means it does not the cost does not increment from the seed value that is issued at the point of redistribution. It stays the same. It stays 20 throughout the entire OSPF domain. If you use N1 or E1, that cost will increment on a per hop basis throughout the network, based off of the cost of the link. And so we have path selection preference. It's E1 over E2 versus over N1 versus N2. Now they're both leaving the network, but the idea is you're going to prefer, if you have E1 over E2, you should prefer E1 over E2. That's the general idea, and that's a route type specific caveat with OSPF. Again, it doesn't matter what the cost value is. That has absolutely nothing to do with it. If you're going in there, if you have a situation where you have, when choosing the best path, 2 E1 routes, lower metric wins. So if you have E1 with the cost of 20 and E1 with the cost of 21, lower metric wins. It's better. It's closer. So E2 routes will choose the shortest path to the ASBR, and N1 and N2 the metric of the route with the forward metric. And we're going to talk more about that later on, but the forward metric is going to be, who do I forward the traffic to? The forward address or to the advertising router? And that is only affected in external routes, like we saw in NSSA. So hopefully I did a good enough job to explain how that would work, but if not, do let me know and I will go through and try to figure some stuff out for you. So BGP redistribution, it uses the origin code of incomplete or the question mark, meaning it doesn't know where it was originated from. Normal eBGP and iBGP loop prevention. So iBGP to BGP denies OSPF external routes by default. So redistribute OSPF, the process ID number, and match internal and external, and then it'll bring the external routes in. BGP to IGP. If you are redistributing eBGP routes allowed, iBGP routes denied by default. So, because iBGP has an AD of 200, we have not covered BGP in this section yet, so I'm throwing that out there so you guys know this. So if you want to redistribute iBGP routes into IGP, you'd have to use the term BGP redistribute internal. I don't ever recommend you doing this, and I'm not even going to demonstrate it. I'm just going to throw that out there that the possibility is there. So, there's some other capabilities that are out there that can cause some looping, like you're doing summarization and the AS set information is missing, so you're missing AS path information, things like that. So as we go through here, and we're going to take a look at why routing loops occur. So redistribution causes loss of end-to-end calculation and loop prevention. So because eigrp and OSPF are not compatible protocols, their algorithms don't speak the same language. They're not the same protocol, same algorithm. So the general idea is this: if I redistribute eigrp into OSPF, I have to specify what I'm going to be redistributing it as. If I redistribute OSPF into eigrp, I have to specify a metric. That's how you can tell eigrp how to handle those routes. Same thing with OSPF. Looping cannot occur with a single point of redistribution. So the internal routing process prevents this, and you might want to know why. The router ID. The router ID is set in all outbound routing updates to say where the route came from. So if you have, and you can specify this, and there's some ways to choose based on the distance command to choose which way traffic is going to forward. But if you have the router ID of the gateway to where you're learning that route from, then you can specify it in there. You can override it with the distance command, and there's some other filtering mechanisms that are out there that we can take a look at later on. So, single point of redistribution, it is absolutely impossible, at least as far as I know, to have a routing loop. Now, loops can occur if multiple redistribution points and wrong paths is selected due to wrong path has lower metric than correct path, or lower path has lower AD than correct path. So, the way you can identify these is a couple different ways. And this pretty much brings us to the end of our slide deck. There wasn't a whole lot to talk about. The general idea is this. If you can visually trace the route, so you do a trace route to a destination, and if it goes in and starts looping, you know you have a loop. Connectivity tests that you can use would be a TCL script, which is what this guy looks right here, which means you can ping, and you can also do a trace route from it. And you can say, let's trace route, see exactly how we're going to get there. And then it's going to do a trace route for every subnet that you punch in. Debug IP routing will help. The IP route profile, which will tell you how many changes there have been made and things like that. You can do a trace route, and preventing route feedback is how to prevent routing loops depends on why the loop occurred. You know, was it a metric-based loop, so a fix with ACL prefix list or tag filtering with AD, and you have administrative distance is generally fixed with only with AD. So we'll take a look at how to fix these as we go through here. So what we're going to do, the first one we're going to take a look at is we're going to go on router 6, and on router 6 I'm going to type in eigrp, I'm going to type in topology base, and then I'm going to type in redistribute OSPF. I'm going to say 6 question mark with a metric. I'm going to give it a metric of, we're going to say 100,000 with a delay of 1, with a reliability of 255, which is 100% reliable, with a load of 1, which means it's not loaded, and then a MTU 1500. Now I've just done one-way redistribution. Okay, so I've done one-way redistribution, which means in eigrp now, if I was to go to router 9 and type in show IP route, I should have a bunch of external routes in here. Okay, and I do. Right? They're all coming in. I'm learning router 1's loopback in here. That's a great sign. Now if I go to router 1 and do a show IP route, I am not learning any external routes. Why is that? Because I haven't redistributed eigrp into OSPF yet. So let's go to router 6 and do that. We're going to type in router OSPF 6, redistribute eigrp 789, question mark, subnets, and you can specify the metric if you want to, but by default it's going to have a metric of 20. And you can also specify the metric type, metric-type, as either going to be external type 1 or external type 2. Remember, type 1, the metric will increment throughout the domain. Type 2, it will not. I'm going to go with just this guy. And now I'm going to go to router 6. I'm going to go to router 1, hit the up arrow, and now I should have a bunch of, it might actually take it a minute for it to propagate here. There they go. So now I have a bunch of E2 routes. What does that mean for you and I? So that means for you and I, if we were to move over 14, let's see here. Is 101 in here? 101. Yes, it is. So I'm going to do a trace route to 101.0.0.14. and it gets to where it's got to go, and it load balances to 2 to 4, and then from 3 to 5, then it goes 3 and 5 to 7, and then it goes, 6 and 13 to 7, then 9 to 14. So it traces. In order for a trace route to work end to end, the source has to know how to reach the destination. The destination needs to know how to reach the source. It's going to be bidirectional. But if you notice, we've only let me go to routers at 10. Go to 10 real quick and do a show IP protocol and show IP interface brief. Okay, so 10's in there, so it's got to be 14 then. That's the problem. So show IP protocol. That's our problem. So show IP interface brief. Let's go to config T and type in router eigrp 789 and type in network of 10.0.0.0. Now we go back over to router 1 and hit the up arrow. I should have 14 in there now, and I do. So now I should be able to trace route to 10.255.14.14, and I can. Now, now here's the true test. Now when I'm doing that, I'm sourcing it off of the 172.16.124.1 address. What if I was to source it off my loopback 0? Source off of loopback 0. If I can still reach it, that means that router 14 knows about my loopback. Let's go to 14 and do a show IP route. And there it is. I've learned that route in. Everything looks good. I'm good to go. Now, we're going to add a complexity here. Then we have a single point of redistribution. We want to go to a 2 point of redistribution. We're going to go to router 13 now. This is where things start to get interesting and start to break if you don't do things correctly. So we're going to type in router eigrp CCNP. We're going to type in topology, address family IPv4 autonomous system 789, and then topology base. Type in redistribute OSPF 13, metric of 100,000 and 1 255. 1 and 1500. Type in router OSPF 13. Type in network or redistribute eigrp 789 subnets. Okay, that's all we've done. Now let's go to router 1 now and hit the up arrow. Okay, nothing's really changed though. Notice that. Doesn't change on our end. It changes on 3 and 5 and 7. Okay, let's do a show IP route now. We should have dual paths to most of our places. Now, we're going 6 on 3 because it's only got one connection, which is fine. And as you can see, it's got actually we'd have to go down to 13, so that's my fault. So let's jump out here and do a show IP route. We should have some paths are double. And notice how some routes are going to go via eigrp. They're external eigrp. And we have some internal OSPF. Also, we're learning some external OSPF routes. So as it sits right here, everything looks good. Let's go to router 1 and do that trace route again. And it got to where it needs to go. The question is why? Why does it know where to go? Well, simple. We're learning in traffic and we're seeing where it's going to go. So, when we redistribute eigrp, let me pull out my pencil here and draw this out. This will make a little sense here pretty quick here. We go red. Okay, so when you redistribute 6 on 6 and redistribute eigrp into OSPF, it's advertised with the 170. Okay, same thing here. Redistribute this into here, OSPF into eigrp, or eigrp into OSPF, 170. Okay, so this means when 6 advertises that route out to this guy and to this guy, when he learns that route in on this guy, he learns it in as 170, and he receives these routes in via 170. Well, he's also learning these routes via OSPF and eigrp. So the general idea with this is very simple. If you are learning a route, and these are eigrp being advertised to OSPF, if you are learning them via OSPF external, they're an E2 route. So on router 1, it's an E2 route, right? So if I look at 10.255, it's an E2 route. My end destination is on, let's say on 5, and we jump out here, we do a show IP route for 10.255.14.14. Our traffic is going to choose us to go out to 56.00.1. Why we go there, it's because, whatever the case might be, just because of the fact that they connected that way, and it's the older route maybe. I'm not exactly sure why. So we have that in place. It's going to choose to go 6 over 13. So we do a show IP OSPF database for the external of where is it? Where did I type that in? We are learning it via 6. We're learning it via 13. And the routing bit is set for both. So technically speaking, it should... They're identical routes. So why it's choosing to go this way over the other way is unknown to me at this point in time. It should technically load balance it, actually. And I think it does. If I look at the trace route. Let's trace. It does load balance it. Okay, so it load balances the traffic out to router 6 and to 13, which is good. Which means both routes are there. If we do a show IP route, just a show IP route in general, show IP route, we should have dual paths to that guy, which we do, which is a good sign. So we're choosing both routes to get there. So we're choosing both routes to get there, but because of the fact that we're learning as an E2 route, we're learning it via OSPF. OSPF E2, it's an AD of 110. So we're going to choose OSPF to go there over eigrp. Because eigrp is advertising it at 170. If we look in here, we do a show IP. Well, unfortunately, because eigrp is not on this, not here, we're going to choose OSPF to get to there. And that's the general idea with redistribution. That's why I set it up this way. We won't have any problems for that reason. Now, if we were to, and I don't, quite frankly, I don't know how to inject an issue, because unless we were to, like for instance, make the administrative distance on 13 lower than 110 and choose, prefer eigrp over OSPF. So let's try that real quick. Let's go to 13, and we're going to advertise router eigrp CCNP. We're going to type in address family IPv4 autonomous system 789 and type in the distance command. So it's going to be under topology base, I believe. Yes, distance for eigrp internal is going to be 109, and external is going to be actually let's make this 90, and external is going to be 109. Now when we do that, what's going to end up happening now is, because we're preferring eigrp now, so this may, or I'm not 100% sure if it's going to cause a routing loop. So let's go to router 1, and so we reconfigured, or I'm sorry, refreshed. So let's do a trace route again to that address. It still gets to where it's got to go. So by changing the distance, it didn't have any effect on it. So I'm going to remove that command because I don't want that to mess anything up. So do show run pipe section eigrp. The main point that I wanted you guys to understand is, because the fact that these routes are being learned via OSPF, and they're mutually redistributed in. Because it's both OSPF, it's going to choose OSPF to get to where it's got to go. And the only time I've ever seen this happen, and because we're doing mutual redistribution, it's two-way mutual redistribution on both routers. You can run into problems where if you redistribute in on 6 and out on 13, then it's not going to have that capability because it's only going to be learning it in, and you could get it to loop that way because then it's going to be advertising OSPF here, and then it's going to be preferring this route out. It's only going to know one way. So, or it's only going to know how to do asymmetric routing. So as far as I'm concerned, everything we've done so far has made everything work the way we need it to. I don't really see any issues that we could potentially have a problem with getting where we need to go. It's the, you know, you got to be careful when you're setting this stuff up. And I unfortunately, this is as far as I usually take redistribution. There are ways that you can filter routes out. We've already talked about that. But like for instance, if you have a situation where you're preferring one, the safest way to do this is if you would mark any eigrp routes, let's say with a tag of 789. A tag is simply a data plane filter, or a data plane metadata. It's a data that's added to the eigrp updates and says, okay, in the show IP route config, I want you guys to set a tag of 789. This tag is going to be propagated all the way through here. So router 1 will see it. Doesn't matter what protocol it is, it translates between them. When the traffic is learned back in on 13, I want you to deny that traffic inbound. So we have only one way. It's only going to be receiving that traffic in. Same thing over here. When I learn traffic in on 13 from OSPF, I want to deny that traffic back in. So the idea is eigrp is learned in this way, potentially could be learned that way. You want to deny it from being learned in. Same thing with OSPF. It's learned in this way, and if it comes back in through redistribution, you want it to not be learned in back that direction. So a tag helps you. So you set the tag outbound, and as it comes back in, you deny. So permit 789, and you deny 789. And that's how you would do that. And that gives you that flexibility to manipulate your traffic. So, as it sits right now, we have full reachability. And that was the main thing that I was looking for. So what I'm going to do is I'm actually going to blow away the routing adjacencies here. And I'm going to turn OSPF and eigrp off on these routers, because I only want to do one redistribution video. If you guys want to see more, let me know, and I will do my best to come up with some scenarios on how that we could break it. But as far as I'm concerned, I don't remember seeing anything crazy on the exam on redistribution. There was a couple on there. Obviously, there's some questions about redistribution, but I don't believe there's any looping. And I'm sure you could cause one if you wanted to, but I don't see the value in showing you one. Because if you're doing mutual redistribution, AD-based manipulation might help you, but in this case, it really doesn't. So that's pretty much redistribution. So next thing we're going to get into is BGP. We'll get into BGP, I'll run through BGP, and then that'll get us into our DMVPN, and eventually we're going to run BGP as the underlay between these guys, and then we're going to run the particular protocol over a DMVPN, encrypt it, and all that good stuff. So we're getting there. It just takes some time for me to get to the material. So I hope this has been informative for you, and I thank you for viewing.